In our last video, we walked through getting started with GlareDB in R so that you can pull data from all of your different data sources into R using SQL. In this video, I'll show you a practical example, pulling data together from Postgres and hosted JSON files using GlareDB in order to run a customer segmentation analysis in R. Today, we'll be running a segmentation of e-commerce customers using transaction and clickstream data. Customer segmentation is the process of dividing a company's customer base into distinct groups that share similar characteristics. In our case, we're going to use k-means clustering, an unsupervised machine learning technique, to identify these underlying groupings based on things like customer behavior and purchasing patterns. For instance, we might identify segments such as people who make fewer or larger purchases, or segments for people who add items to their cart but frequently don't complete their purchases. Understanding these segments enables us to create more targeted business strategies. We're going to use GlareDB's ability to seamlessly work across different data formats and R's analytical capabilities in order to run this segmentation and uncover these distinct customer groups. All right, so let's get started. I'm going to be working in RStudio, but of course you can run this anywhere you can run R. I'm also going to turn warnings off here, and that's just because I know there are some warnings that come about having to do with like float precision, which aren't super critical for this case. So the first thing you're going to want to do is you're going to want to install the packages needed here. And so in addition to GlareDB, you're going to want to also install dplyr, ggplot2, facto extra, scales, and tidier. Of course, I'm going to include a link to the full script down in the description, so check that out in case you have any questions. So after installing all the packages, you're going to import all of them. And then you're going to set up your GlareDB connection, which is going to enable you to query your various data sources. Once you've done that, let's take a look at the data that we're working with. So we have transaction data that's in Postgres right over here. So let's just see what that looks like. And so we see here we have these columns: transaction ID, customer ID, amount, and date. So these are individual purchase transactions from different customers. And then over here, in a hosted JSON file that we have on GitHub, you'll see that we have a whole bunch of clickstream data. So these are different events that customers have gone through. So we can see things like page view, the action taken, and also a timestamp. Now we can use GlareDB to just join these two data sources together as if they're in the same place. And so what we're going to do is we'll run this, and then let's check out what we get back. So we're joining our transaction data to our clickstream data. You can see that we're grouping based off of their customers. And so each row here is going to represent a customer. It's going to have their average number of their total number of transactions, their average transaction amount, their total spend, total events, number of purchases, number of added to cart, and then total product page views. So after we've saved this to a variable, we've rendered this as an R data frame, saved it to a variable, just looked at it. And now we're going to prepare our data for clustering. So for the first step, we're going to pull the customer ID out because we don't want to be considering that when we're deciding which customer segmentation group each customer belongs to. And then we're going to scale all the features. And the idea here is that we're basically normalizing all of them to ensure that all features are going to contribute equally to the clustering process, regardless of the original units or ranges. So for instance, number of transactions is going to be much smaller than total spend, and we want to make sure that therefore total spend isn't weighted more heavily because of that. Run this. Once we've done that, we're going to determine the optimal number of clusters using an elbow plot. So let's run this and take a look. So you'll see what we're doing here is we're plotting the total within cluster sums of squares against a range of cluster numbers. And what that means is we're looking for the elbow point where increasing k no longer significantly reduces the sum of squares. And this is, in short, going to tell us the optimal number of clusters for our data. So it's kind of like we're trying to figure out, we have a whole bunch of these customers, I think it's about 1,000, and we're trying to figure out how many groups we want to try to segment our customers into. So when you look at this, you can see these inflection points. So there's like a sharp angle change right over here and a sharp angle change right over here. And then it gets shallower as it proceeds and less drastic. And so from looking at this, I would say, hey, maybe 2 or 3 looks like a pretty good number of segments to group our customers into. And so 2 isn't super exciting, so I'm going to pick 3 segments for this case. So once we've decided that we're going to choose 3 different customer segments, we'll pass that in over here, and we're going to use that to run a k-means clustering. So let's run that and see what we get. So if we take a look, this method k-means is a way of sorting our customers into groups. So once we've decided that we're going to have 3 groups, this method puts each customer into the section where they fit best based on their shopping behavior. So it's basically going to group customers into groups of other similar customers. Once we've decided which segment each customer is going to be in, we're going to pass that segment back to our original dataset. So we see here we have all these customer rows, and now we have an additional column, which is going to indicate which cluster each customer is in. Now we're going to visualize each of the clusters using the specific features. So let's run this. We're going to get this plot. So this customer segments visualization is basically like a picture or a chart that shows our different customer groups. It's basically like a map where each dot represents a customer, and customers who are in the same group are all going to be the same color. And you'll see we have 2 main characteristics that we're plotting here. One is going to be the number of purchases, the other is going to be the total spend. And you can see there's a pretty consistent groupings here of like people who tend to spend less also have fewer purchases, and people who spend more have more purchases, which isn't super unexpected. There are other characteristics here that we've included in our analysis, but this is just a way of taking a look at how some of our segments compare with some of our characteristics. So now that we have this plot and these groups, we're going to take a closer look at each customer group to understand what makes them unique. So let's actually analyze the cluster characteristics. We'll take a look up here. And so you can see this is kind of like a personality profile for each customer group. And you can see these are the 3 different clusters, and you can see these are the different characteristics that we've included, the different features. And you'll see that we have number of transactions is fairly different between them. Average transaction amount is not. And then total spend and total events are also quite different. And so you see we have these different characteristics, and average transaction amount probably is not going to be a major thing here. We also have 3 more variables. We're going to be able to visualize those a little bit later because they're not shown here. Let's visualize these key differences between the clusters. Let's take a look. You can see here we have, well, the total spend is the more drastic one. We also have total events, which is, this looks very small in comparison because we're plotting basically plotting these as like absolute numbers. But you can see here that we have these 3 different groups, and you can see for each of these attributes how they compare. Once we've done this, we're going to name the groups. And so here in this case, I think these labels don't really apply correctly. So let's relabel these. So our 3rd group appears to be the one that are the high activities and spenders. And so let's put that here. Our 2nd group appears to be the potential converters. So they're the ones that have the lowest total spend and also the lowest number of events. And then our 1st group, these are kind of in the middle. It looks like they have a decent number of events, they have a decent amount of spend, but not quite as high as the 3rd group. So let's call these maybe like mid browsers. All right, and now we're going to rerun this. And we can see here, if we take a look at our customer segments, you can see here we have for each of our customers, we can see now their cluster and also the name of their segment. And finally, let's take a look at the feature importance for this analysis. So this is basically going to tell us how significant each feature was in assigning groups for each customer. And so you can see here, total events winds up being the most important feature, but total spend is also quite important, as is number of transactions. And we can see here that average transaction amount is not very explanatory at all. So there you have it. We've just run a customer segmentation analysis in R. We've been able to pretty seamlessly pull together 2 different data sources. One is a JSON file hosted on GitHub, and the other is a table in Postgres. If you wanted to, you can use GlareDB here to pull in data from Snowflake or MongoDB or MySQL. The sky's kind of the limit here, and it's going to make these cross-platform analyses much, much easier. Please let us know if there are other examples you'd like to see in R or in other languages. Of course, like, subscribe, do all of those things. And Yeah, we'd love to hear from you. Thanks all.